Hi everyone, many thanks for coming to check out my poster. I hope you're all doing well and keeping safe. So I'm just going to provide a very brief overview of the first set of experiments I've conducted for my PhD research, which focuses on how the memory resource described by Bayes and colleagues is allocated to visual items. So this research by Bayes et al. Built on and contrasted previous work by Zhang and Luck in 2008, which suggested that there are a limited number of slots in memory, with each slot able to hold one object representation at a fixed resolution. In contrast, the resource model described by Bayes and colleagues proposes no such upper limit, stating that a memory resource is distributed evenly to all items in a visual scene, with the resolution of object representations a declining function of the total number of items. So the experiments I'll discuss here provide an initial look at how this resource may be allocated to visual items by combining the use of change detection and task switching paradigms. Now, typical task switching paradigms involve switching between performance of at least two tasks. However, in this set of experiments, the task was always change detection. The switching aspect instead related to which feature dimension was relevant on a given trial, with stimuli displaying color and orientation. So in pure blocks, the same feature dimension was relevant on all trials, for example, all color trials, while in mixed blocks, the relevant feature dimension could repeat, for example, consecutive orientation trials, or the relevant feature dimension could switch, for example, a color trial followed by an orientation trial. A consistent finding from the task switching literature is that error rates and response times within mixed blocks are significantly increased when there's a requirement to switch task compared to when the task repeats, referred to as the switch cost. So these experiments aim to investigate whether the same effects presented with a dimension switch rather than a task switch. So stimuli in experiments 1A and 1B were bivalent, displaying both color and orientation, while experiments 2A and 2B utilized univalent stimuli, with 2 displaying color and 2 orientation. In experiments 1A and 2A, a change only occurred in the cued feature dimension, with an additional constant change in the irrelevant dimension employed in experiments 1B and 2B. So while there were several analyses conducted, I just want to briefly touch on accuracy. So the results from the accuracy analysis showed that within mixed blocks, the requirement to switch feature dimension significantly impacted performance compared to when the feature dimension repeated, but this only occurred when there was an additional constant change in the irrelevant dimension. So it's possible that this reduced performance observed on mixed switch trials is due to a misallocation of resources, with two accounts from the task switching literature, namely task set inertia and task set reconfiguration, providing potential explanations for this disruption. So the next experiment in this series aims to confirm and extend these findings with the pre-registration available on the Open Science Framework. Thank you very much for listening.